Hello, good day. So we are group 9. So this is our semi-final video. So our topic is manual radar plotting. Course outcome. Manual plotting techniques giving the information from the radar observations. Learning outcomes. At the end of the session, the student shall be able to comprehend the history of maritime navigation, radar, determine why radar is such a valuable tool, recognize the ship parameters. Importance of the topic. The students can perform manual plotting techniques given the information from the radar observations. History. New technologies of radar become available to merchant shipping with the end of hostilities in 1945. Radar on merchant ships was initially installed for commercial purposes on ferries to maintain better schedules in fog and large fishing vessels. Radar was treated with great suspicion by the mariners. With improving technology and after some time, the use of radar for safety purposes was recognized. Misinterpretation of radar information had not resulted in any reduction in the number of serious collisions at sea. International Conference on Safety of Life at Sea in 1960 revised the international regulations for preventing collisions at sea by adding rules to take account of the use of radar and recommendations on the use of radar information as an aid to avoiding collisions at sea. The International Conference on Safety of Life at Sea in 1974 adopted provisions to the SOLAS Convention, making radar a mandatory carriage requirement for merchant ships in a PACE program starting in 1980, which finally completed in 2002. SOLAS requirements. All merchant ships of 300 gross tonnage and over now shall carry a radar and many carry two. IMO adopted performance standards for marine radars, which are used in connection integration with other navigational equipment required to carry on board ships such as an automated target tracking aid, ARPA, AIS, ICDIS, GNSS, and others. And that's all. Thank you.
Good day everyone, I am the Cadet Toledo and I'm going to report my assigned topic, non-SOLAS shift. Many small crop millions also carry radar voluntary as manufacturers have produced cost-effective designs for their needs. The master's or shipmaster's point of view. The key facts are that radar reminds and will remain the primary system for collision avoidance, and radar is very important tool for navigation to avoid collision. Why radar such a valuable tool? The master and watchkeepers have confidence in information radar provides because its operation is ship-based and it's not reliant on third-party sources, and it has a proven track record, and radar is useful with SARTs when engaged in source and rescue, search and rescue. In short, In its display, reader offers the watchkeepers the basic reality of all targets related of or to the ship. It therefore aids and watchkeepers and helps in decision making for both navigation and collision avoidance to avoid collision. Collision avoidance. Early action is required to avoid a close quarter situation. Therefore, early identification of closing targets is essential to avoid collision. Watchkeeping officers need to be competent in the use of the radar and are trained in its use and the application of ARFA. Some IMO requirements. Maximum emergency stopping distance from full speed of the ship should not be more than 50 meters ship's length or 15 ship's length. Emergency turns radius of the ship should not be more than 2.5 ship's length. Ship parameters. Speed up to 25 knots. Length largest container ships 335 meters. Capsize bulker 300 meters. Panamax 220 to 230 meters. Shift parameters. Emergency stopping distance 3.3 kilometers to 5 kilometers or 1.8 nautical miles to 2.7 nautical miles. Emergency turning radius 550 meters to 840 meters or 0.3 nautical miles to 0.45 nautical miles. Displacement weights 100,000 to 200,000 50 tons. Practical requirements. To start plotting targets and determining their course and speed when the target is between 8 and 10 nautical miles up. That's all for my assigned topic. Thank you.
Good day everyone, I'm Cadet Tantoy Lyndon. I'm here to present about navigation. Radar gives accurate information on distance from charted features and assists in maintaining the ship's course. So this is the use of the radar. Radar will normally show a 60-meter high landmass at range of 20 miles. This is considered by seafarers as minimum requirement. Discrimination of target from watchkeeper perspectives. To be able to distinguish a tug from its tow at sea at 12 miles range. Approaching a rig on a supply vessel. To clearly identify the standby boat from the rig at 6 miles range. Number 2. To be able to distinguish anchor, pennant, buoys of semi-submersible rig at 3 miles range. Resolution MSC .192 close open parenthesis 79 5.5.1 range. The radar system should be capable of displaying 2 points targets on the same bearing, separated by 40 meter in range. As to distinct object, 5.52 bearing, the radar system should be capable of displaying 2-point target on the same range separated by 2.5 degrees in bearing as distinct object. Radar greatly assists navigation during poor visibility. Pilots rely on radar at close range in reduced visibility to pass buoys and beacons. Resolution MSC 192.79. Minimum range. With on-ship at zero speed, an antenna height of 15 meters above the sea level, and in claim of condition, the navigational buoy in Table 2 should be detected at minimum horizontal range of 4 meters from the antenna position up to range of 1 nautical mile without changing the setting of control function other than the range scale selector. Engineering terms. Res ITU RM 1313. Power 30 to 70 kilowatts. Horizontal beam width 0.75 to 4 degrees. Pulse width 0.03 to 1.2 microsec. PRF 4,000 to 375 SZ. Noise figure 3 to 8 decibel. Antenna pitch 3 degrees. Roll 25 degrees. Yaw 5 degrees to vertical beam width 20 to 30 degrees. That's all, sir. Thank you.